we are still in the chapter of vector spaces and subspaces, and we are in the subchapter of direct sum. Okay, so we have vector space R3, and we have U, a subspace, the xy plane, and W, another subspace, the z-axis. Okay, let us say that U is the xy plane, so that will be the vectors A, B, 0, where A and B are in R, in the reals, and W, so it is the z-axis, so it will be vectors in this form, 0, 0, C, where C is a real number. So let us see if R3 is a direct sum of our U and W. Okay, so we pick an arbitrary vector in R3. Okay, so it will have this form, and every single vector of R3 can be written in a unique way as a sum of vectors in U and vectors in W. Okay, so 1 and 2, the intersection of U and W, well, the only vector that is in the intersection of U and W is the vector 0, 0, 0. Right? So the intersection is only 0. So we can say that R3 is a direct sum of subspaces U and W. Okay, yet another example. We pick the vector space R3, and let us see if R3 can be written as a direct sum of subspaces U and W, where U is the subspace with vectors A, B, and C, where A is equal to B and is equal to C, and W is the vectors 0, B, C. So 0, B, C, this is the YZ plane. Okay, so if we pick U intersection W, so A, B, C will be vector 0, right? Because if we pick a vector V, A, B, C, and if this vector is in the intersection, that means that A has to be equal to B and equal to C. And do not forget here, A is 0. So if A is 0, this one will be 0. So B will be equal to this one will be 0, and this one will be 0 too. Okay, so this means that A is 0, B is 0, and C is 0. So vector V will be the vector 0, 0, 0. Okay? Okay, and easy to see that R3 can be written as a sum of these two subspaces, right? Because if we pick a vector V, but not here, a vector V, let us say ABC, an arbitrary vector in R3, so vector V will be written as AAA, since these they have to be all equal, plus 0, and B Okay, but what is B? B is B minus A and C minus A, right? So if we add these two vectors, right, we will get A here, A plus B minus A, we are going to get B, and then A plus C minus A, we will get C. So so both conditions, 2 is checked and 1 is checked. So yes, R3 can be written as a direct sum of these two subspaces.